If you look on the expansion board, this blue one was previously controlled when we used the NRF52842, but what we did last time was with the DS18AX20, which is just a stop sensor. It measures both temperature and humidity. We will control the DHT11 one-stop sensor, so please insert the module, and then we will also display this information on the OLED display, so please kindly connect it in exactly the same way as shown here. To control the DHT11, this time you need to add the DHT-related library code to the library folder. If you simply go to this link, you will just see the source code. Please copy it all entirely. Then, in the library folder, carefully create a new file and paste it appropriately as DHT and save it correctly. Next, I will open the code, delete it, and try writing the code. The following information pertains to the value obtained from the text import function, specifically involving the dynamic link library file known as dcp.dll. This file is crucial for certain operations and is associated with the type ISQC, which stands for a specific quality control standard in software development. The process of importing from a text file using dcp.dll involves several steps, including the initialization of the import function, the verification of the file's integrity, and the execution of the import command. The type ISQC ensures that the data imported is of high quality and meets the necessary standards for accuracy and reliability. This process is essential for maintaining the integrity of the data and ensuring that an HTTP To ensure accurate data collection, start by executing the measure command once. This step is essential to prepare the system for the following commands. After this setup, proceed with the temperature command to obtain the current temperature reading. Then, execute the humidity command to gather humidity levels. These commands are crucial for collecting the necessary environmental data. Once you have this data, clear the screen to remove any previous information, ensuring clarity. Finally, verify the temperature, again, to confirm the accuracy of your readings. This process ensures that all essential data is collected and verified, maintaining the integrity of the displayed information. By following these steps, you ensure that the data is both accurate and current, which is critical for any further analysis or decision-making processes. Temperature. To achieve the desired outcome, ensure the information is displayed on the right side of the screen. This involves placing relevant data, notifications, or visual elements on the right-hand side, where users expect supplementary information. Additionally, display this information on the console, which is the command line interface or terminal for inputting commands and receiving feedback. By showing the information on both the right side of the screen and the console, you make it accessible to users interacting with the system in different ways. This dual display strategy enhances user experience by providing multiple access points to the necessary information. Please output it like this, and I will run it once. I am currently running it. The temperature and humidity are displayed here every 2 seconds, and this is what we checked on the console. Now, let's check it on the actual OLED display. As you can see here, the temperature and humidity are displayed on the OLED display. I often wonder if the atmospheric temperature will change in the near future. but it doesn't seem to be changing. The humidity levels are gradually changing a little bit. In this way, you can measure both temperature and humidity using the DHT11. This time, I controlled the DHT11 temperature and humidity sensor on the expansion board using MicroPython and Raspberry Pi Pico. I will see you next time with another topic.